warp speed, these huge structures around stars, even messages sent using gravity. Science fiction is full of these really wild ideas.
Absolutely. And today we're doing a deep dive into that. We're looking at three pretty mind-bending concepts: warp drives, Dyson spheres, and something called graviton communication.
Right, trying to figure out what's maybe possible based on physics, what's stretching things, and what's, well, just pure fantasy for now.
Exactly. Where does the science actually stand? Let's start with warp drives, the classic, Star Trek image.
Yeah, zipping across the galaxy. It's such a core sci-fi dream.
Yeah.
That faster than light travel. But physics has something to say about that, doesn't it?
It certainly does. Einstein's relativity is pretty clear. Nothing with mass can accelerate past the speed of light. It's like a fundamental cosmic speed limit.
Hard stop. So, how do we even get the idea of warp drive then? Is there any kind of loophole?
Well, there's a really clever theoretical one, a mathematical solution proposed by Miguel Alcubierre. It's called the Alcubierre drive. And the key is it doesn't actually propel the ship faster than light through space. Instead, it warps space-time itself.
So it compresses space in front and expands it behind.
Yeah.
Kind of like you're on an airport moving walkway.
That's a perfect analogy, exactly. The space itself does the moving for you, carrying the ship along in a sort of bubble.
Okay, that sounds incredibly cool. But I sense a but coming. What's the catch?
Oh, it's a big one. This requires something called exotic matter, specifically matter with negative energy density or negative mass.
Negative energy density. What does that even mean?
It's stuff that would essentially push space apart, creating that expansion needed behind the ship. The problem is, well, we've never seen anything like it.
So it's purely theoretical. We have no idea how to make it.
Not a clue, currently. So, fascinating mathematics, but practically. Yeah, seems impossible right now.
Okay, possible for now.
Wait,
Let's switch gears then. What about harnessing a star's energy? Dyson spheres. That sounds almost as ambitious.
It is ambitious, but in a different way. This isn't necessarily breaking fundamental physics. It's more about scale, colossal scale.
Right. The idea of building a structure around an entire star to capture all its energy sounds straight out of, advanced alien civilization plans.
Yeah, and interestingly, it came from a physicist, Freeman Dyson, back in the 60s. He wasn't thinking of a giant solid metal ball, though, that would likely collapse.
Oh, so what was his idea?
He imagined more of a swarm, billions, maybe trillions of independent satellites orbiting the star, like a cloud of sparkling fireflies, each collecting energy.
A Dyson swarm. Okay, that sounds slightly more plausible than a solid shell, maybe.
Yeah.
But still, the materials needed.
Exactly. The raw material required would be astronomical. We're talking about dismantling planets, maybe the entire solar system, just to get enough stuff.
Wow.
And the engineering? Just coordinating billions of satellites. We're nowhere near that level.
But it's theoretically possible within known physics. Just way beyond us.
That's the key difference, yes. The physics allows it. And here's the really cool part, the aha moment.
Yeah.
Astronomers are actually looking for these. They scan the sky for stars that have unusual heat signatures.
You mean looking for signs of alien-built Dyson spheres?
Precisely. If a structure is blocking a star's visible light but re-radiating that energy as infrared heat, it might show up in our telescopes as a potential technosignature. Evidence of advanced life.
That's incredible. So a sci-fi concept is actually guiding real astronomical searches. Okay, third one, graviton communication, using gravity itself to send messages.
Yeah, another staple of, far future sci-fi. Sending messages faster than light using hypothetical particles called gravitons.
Hypothetical. So first hurdle. We don't even know if gravitons exist.
That's hurdle number one, yes. They're predicted by quantum gravity theories, but we haven't detected them. And hurdle number two is gravity's weakness.
It feels strong to us, keeping us on Earth, but cosmically.
Cosmically, it's incredibly feeble compared to, say, electromagnetism. Detecting even a single graviton, theorists estimate, would need a detector basically the size of Jupiter.
Jupiter-sized. Okay. So, not exactly practical for building a communication network?
Not even remotely. But there's an even bigger problem, a fundamental physics issue.
Which is?
Faster than light communication, whether via gravitons or anything else, seems to break causality.
Causality. Cause and effect.
Right. The principle that a cause must always happen before its effect. If you could send a message faster than light, you could potentially create paradoxes, like receiving a reply before you even sent the original message.
Okay, yeah, that sounds like it breaks the universe's rules pretty badly.
Physics really, really doesn't like paradoxes. So faster than light communication via gravitons. Beautiful idea for fiction, but physics seems to put up a very firm no.
So wrapping this up, warp drives. Fascinating theory, neat impossible stuff. Dyson spheres. Theoretically doable, just monumentally beyond our scale. Graviton communicators. Probably breaks physics itself.
That's a pretty good summary. It shows how science fiction can play with the known rules, like with Dyson spheres, or propose ideas that require new rules, like exotic matter for warp drives, or even bump up against the most fundamental rules, like causality.
It really highlights that amazing interplay, doesn't it? Science fiction dreams up these incredible things, and science investigates, sometimes finding pathways, sometimes hitting walls. But the dreams themselves can inspire.
Absolutely. Think about rockets to the moon. That was pure fantasy once. Imagination is often that first crucial step.
So maybe the thought to leave everyone with is, when you next see some wild sci-fi tech, ask yourself, is this tomorrow's breakthrough, waiting for the right discovery? Or is it a really cool idea that helps us appreciate the rules of the universe we actually live in?
A great way to think about it. That tension between imagination and reality. That's where so much discovery happens.